Hello. Hello. I'm gonna wait a few minutes before a few more people join the stream. All right. I think I'll start introducing myself. My name is Isuru Daulagala, and I went to school in Sri Lanka at Trinity College. So from grade one until until my A-levels, I was at Trinity, and I thought of coming to the US for my undergrad when I started my A-levels, and there was a few people in at Trinity who were trying to do the same. I was kind of late to the game, and uh, I started applying pretty late as well, and I came to a university called Drexel University in Philadelphia, and I majored in um, electrical engineering and computer science. I double majored, and the school that I went to, Drexel, has this thing called a core program, which allows you to do like multiple long-term internships at different companies. And this made me kind of explore like all different aspects of electrical engineering and computer science. I started off at a company called PJM Interconnection, which was like a transmission power transmission company where I did like some software development work. Then I also worked for a few different companies, including Micron Technology, which is a pretty big memory manufacturer in the world. So at that point, I was interested in like computer architecture, like low-level hardware, and then I was also interested in computer vision and there was some work that I did at Drexel that was related to computer vision. And I interned at NVIDIA for like 6 months. Then I came back full time, and I've been at NVIDIA for 2.5 years now. Um, and a lot of the work that I do at NVIDIA right now is probably applied machine learning, if I could say, trying to um, use machine learning in internal tools, internal like work flows. One of the areas is like circuit design. You can abstract a lot of circuit design problems into graph problems. So there are instances where you can use uh, like graph-based approaches to solving issues. So I think that's a kind of very hasty introduction of what I'm doing and where I am. While I was interning at NVIDIA, I did look at like a lot of other companies, and I was a little bit more like later on. I think I did get an offer at Google, but the difference between, let's say, Google and Facebook, which are the two big companies, and a lot of other companies, is that you join Google, like you get a job at Google first, then they decide which team that you work on. Since I interned at NVIDIA already, I knew the team that I was working on, which is pretty like a team that was very focused on research. So I joined them because I was comfortable with people I worked with. How did you get into machine learning? So there was a elementary computer vision course that I took at the school I went to. And I learned, this was in like 2013. A lot of the big breaks in machine learning related to neural networks came out of the 2012 ImageNet challenge. So um, if I can go back to the ImageNet challenge, the ImageNet challenge is essentially like a challenge that happened between 2012 and 2018, where you had like large amounts of images, let's say around a million, and you had 100 to 100 200 classes, which are like different types of images containing different classes. So like you would have a image of a dog or a cat or a car, and the objective of the competition was to predict what the label of the class was. And until 2011, all the approaches that were taken were very like you couldn't intuitively explain why people use them. But like in 2012, the big breakthrough was AlexNet, which used convolutional neural nets to predict those classes. And it was pretty big news at that time. So that's when I got interested in machine learning through a computer vision course. And then I took another class on, I think the area was called, that I did research was image forensics with a professor called Matthew Stam. And that's when I got like more exposure into, like, let's say convolutional neural nets. And at that time there were like a few other neural net architectures like deep belief networks, but like then I understood why convolutional neural networks won through, and that's how I kind of got exposed to machine learning through neural nets. Um, okay, so the interview process for any, let's say, big company, which is the big four right now, um, Google, Facebook, Amazon, and Microsoft, and then there's like companies. So it's true for those four, and also for the next tier of companies like say NVIDIA, Uber, Lyft. What happens is you have to reach out to a you have to reach out to like a recruiter, or recruiter reaches out to you, and if you have internships on your belt, it's pretty easy. And then they have a phone screen, so they get an idea what you like. A non-technical person, usually like a recruiter, talks to you, um, and then they talk to you about like what your goals are. Like there are at Google, for example, there are a few different roles. The two big ones are like software development and software engineer, and a site reliability engineer. The site reliability engineer usually make sure that infrastructure runs pretty smoothly. So they give an overview about different types of roles, and then they have a so when the recruiter talks to you, the steps called a phone screen. Then usually they have a online coding challenge. Google used to, and it's true with NVIDIA, used to have their own site, which you could there were questions and you could submit answers. Um, um, the So this is like online question solving problem. So that's the second step. The third step would be you would talk to an engineer, like someone in the hiring process, and they would have ask you a few different questions, like technical questions. Some would be like writing like code on like a Google Doc or like a similar system, and you would solve a problem, write the answer to a problem in terms of a pseudocode or an actual algorithm with the programming language of your choice. And if you pass that, they would have an on-site interview, which means like you would go to Google or NVIDIA or like Facebook, and then at that on-site interview, you would have like 4 or 5 questions they would ask. Like each question would take like half an hour to an hour, and you would solve those questions on a whiteboard. And so essentially you have 3 steps: over a phone screen, a online coding problem, then you solve a technical problem with a engineer, then a non-site interview, you would solve technical questions with multiple different engineers and multiple different teams. Um, then they evaluate you based on like at Google, you would be given a score between like 2 and 4, and you would be like like you would be rated by them, and like usually if you are more than a 3, they would give you an offer, or like they will come to a conclusion like if you are suitable for a position or not. Usually, like places like Google and Facebook, they hire you first and then um, pair you with the job later. At Facebook, especially, like you join the company, then they have like a boot camp where this is for like fresh grads, not like mid-level hires. The difference at NVIDIA was I didn't interview as a fresh grad, I interviewed as an intern. So the application process was much easier, but the internship process was essentially like a long-term interview. Um, so, how did you get an internship at NVIDIA? This is a good question. So, I initially met a few people from like recruiters and like also like a um, different people at like engineers at NVIDIA at a scientific conference, I think. And then I gave my resume. And someone actually talked to me at a poster presentation, and then like nothing happened. A few months later, I reached out to the recruiter again, and she just like forwarded my resume to a bunch of different managers, and they reached out to me personally. So there were like a few different interviews, a few different um, like roles that I interviewed with. Then I kind of like I had like two offers, and I joined the team that I was a little bit more comfortable with. Um, Usually, like the best way to get a hold of someone uh, like to get a job is the first part is the hardest, which is like how do you get recognized so that a recruiter reaches out to you, or you the when you reach out to a recruiter, they kind of have a like they would respond back. That's the hardest thing, and like if you don't have any internships on your belt, that's a little bit hard. There are a lot of people that I know like who have like a lot of good open source projects, or like if you are doing something with machine learning, if you have or like a data science project, or if you do really well in a machine learning competition, which I think I'll talk later, which is kind of like my um, like I've been involved in like online competitions uh, few different times through like for volunteers who work at schools. Um, so you have to get recognized, like you have to have like some good resume. Like if you have some publications, or like if you have some good open source projects in like repositories like GitHub or GitLab or Bitbucket, that's a lot of other people use. Um, how is the how hard is it to get into NVIDIA? I think it depends a lot on the role. I think my team, especially, there are like a lot of people like my bigger team like who have PhD. So um, I think the equivalent team at Google would be like much harder to get in than at NVIDIA. But like Google has more engineers. We have around I think Google has more than like a closer to like 100,000, I would assume, engineers. And it would be easier to join Google because they have like a variety of roles, whereas in NVIDIA there's like only a few. I never interviewed as a fresh grad at NVIDIA because I got an offer. I think of the places that I've interviewed, I think Facebook was probably the longest and the hardest process. They had multiple phone interviews, and like something kind of funny happened at Facebook. Usually, like in on-site interviews, they ask you to solve questions on the board, but um, like an engineer, she gave me her laptop and she told me to solve a specific problem, like a algorithmic problem, and she gave me like 45 minutes, and she said I'll come back like an hour later. So which was kind of different. So different people have different approaches. I think all big companies, the four big companies that I mentioned are Google, Facebook, Amazon, and Microsoft, all pretty rigorous interview processes. NVIDIA, like Uber or Apple, are pretty much the same. And if you're in the United States, the hardest thing to do is to get that first initial phone screen from a recruiter. So for that, you have to have a lot of like good projects or a good resume or like publications in good conferences. Akila, other courses, online courses, no, but I can link like equivalent courses at like, let's say, Berkeley or Stanford. What's the tech stack I currently work on? That's a good question. I'm assuming like a lot of the work that I do is not like related to a like the tech stack like a traditional. I'm not doing like web development, or I'm not doing something based on the cloud. Majority of the things I do is like research. So like we have our own or like trying to make things better. So we have like internal flows where we can run really high compute machines, and you can run algorithms to test. So it's essentially like testing and iteratively making algorithms like related to like machine learning better. I saw a question about computer vision. Okay, yeah. How can wait, before that? What are the key concepts which I lead deep into computer vision? So it's a pretty big question. I think there are different areas of computation. The original area that neural networks were used in computer vision was called image classification. So if you give an image, can you predict if this image is like a cat or a dog? And then more recently, like a few years after that, 2014 and 15, there were algorithms called this area called object detection. So if you're given an image, can you localize where the cat and dog is? Or like image segmentation, if you're given an image, can you label the areas of the image that are like cats or dogs? Then there are like other new areas like so that's the second area. I think image neural networks or convolutional neural networks were used in computer vision. Then now there's a lot of pretty much every area in computer vision, like 3D reconstruction. What else? So these problems can, like image classification or object detection, can manifest in different other sub areas. For example, like you can. So there was a recent competition that I did with a few of my friends, which was called the CVPR mitosis challenge. I'll link that on. So mitosis is a step in like a cells partition. One of the ways a cell divides it to two. So if you have like a cell culture and a video of the cell culture focused on, can you predict when exactly the cells divide into two, or like a cell divides into two? And that can be modeled as a object detection or a image classification problem. So what are the frames that in the image that mitosis event occurs, and what are the events that doesn't occur? Which frames do it not occur? And in the frames that a mitotic event occurs, which pixels do it happen on? So like pretty much all. So then there are like a lot of big areas where you're trying to develop like a new area of computer vision, or like I don't know if you can say it's computer vision, like you take a bunch of images that in the world or real world, and you create like an unseen image. So for example, let's say you have like millions of images of faces, and can you create a face without by training from of those faces? Can you give me what like an average face of like a Sri Lankan male or Sri Lankan female looks like? So it's a sub area of neural networks called generative adversarial networks, which is like a pretty huge area. And when it comes to NVIDIA, I think there are like multiple different areas. Um, I want to put a disclaimer here that the views that I have are like only mine, solely mine. This is not my company's, but saying that disclaimer, I think the way NVIDIA, like I would say, looking from an outside, would approach it is like, how can we make certain neural network applications run better on GPUs? How can you make them faster? So when they're selling the hardware to, let's say, Amazon or like AWS or Google Cloud, you are saving power and money for that cloud provider, and you can like sell more of that product. And I think NVIDIA has their own data center business, which like is also ongoing. So they want to get into the like providing cloud tools to run machine learning applications. So computer vision is a big sub area. I don't know if I answered Hariharan's question. Bad recommendations. Bad recommendations. It's a hard question. Really depends. I think there are problems that are like, so I think we have to look at where we are like in 2018, so in 2019 right now. If you're solving like, let's say a computer vision problem, and if you want to stand out, you want to solve problems that are marginal, that make you stand out. So an area that I think is pretty well like saturated or like mature is like image classification, or given an image and you're given like a million images of them, of types. Can you tell me if the image is of a cat or a dog or a car or a bike? I think there was an ImageNet challenge from 2012 to 2000, until 2019, and the reason why they stopped is because it's the algorithms got so good at predicting, and you can make a marginal improvement, but I don't think that will help. So if you want to your projects to stand out, try to solve a very new problem, or like a problem that's not as like refined or not as explored. I would think that matters more than solving an existing problem, making an iterative improvement to existing solution. I think in terms of software development and like programming, I think the bad recommendations, like learn a lot of different languages initially, which is I don't think it's a good idea. I would say learn a language, preferably something like a language like Python, which is very versatile in different aspects, to learn the key concepts. Let's say, like arrays, or in Python less, like very rudimentary data structures like stacks or queues, and then take a data structure class and explore like algorithms and data structures pretty in depth, like breadth first search, depth first search, um, hashing, that kind of stuff. I think initially, like I learned most of my software, like programming through like two languages, Python and C, which are pretty good. I think C is a very good language to learn because you learn a lot of deep concepts about computers, like memory management, like and like memory, pages, computer architecture through C. So like start with the language you're comfortable, then explore the paradigms associated with different programming languages and different things later on. If I could, like, we are in 2019, I would definitely say the first language you learn should be probably something like Python. And I would never start learning um, with something like C++, which is pretty complex and huge language. Um, the C++ is like a language that I learned later in life. After I learned C, you don't really need C to learn C++. And in hindsight, if I didn't learn C, I would have gotten some bad habits from C to C++. And if you are learning C++ in 2019, start with C++ 11, or which is called modern C++. I think I can link. Um, so like a lot of the things I do is like writing new and more efficient algorithms. So for that, I first write like an algorithm in like a scripting language or like a very um, unperformant language like Python, and then go to something that's performant like C++. If you want to explore different programming paradigms like functional programming, you can like learn something like Haskell, which is I think a pretty um, like a great academic language that isn't used. It's not as prevalent outside, which people are trying to get that. If you learn trying to get into web development, like some like front end, I would learn a lot of JavaScript after I learned like Python in my introductory um, programming language class. So it depends a lot on your what you want to do and what you're interested in. Like when I was an undergrad, I took like um, a lot of different classes. I took like stuff related to web development, and I was like I wasn't that interested at the time. I did a lot of like projects on the side related to web development, but I didn't really like learning it because I felt like the value of learning, I could learn that on the side. Um, Whereas like if you're taking like a computer vision course, you have to learn the math, and it forces you to understand problems with different angles. Um, so how an undergraduate can prepare to enter the industry as a fresh graduate? So I think um, in terms of computer science in like all different areas, the most important class I think is a data structure. So if you are pretty good at algorithms and data structures course, you can be pretty versatile at applying that skills. I think a lot of everything in computer science is essentially algorithms and data structures. So if you that would be a course that I would explore and understand pretty at a deeper level. And if you want to take like a advanced algorithms course, it would be also nice. Uh, sure. Hari. Sorry, going back to Hasith's question, how an undergraduate can prepare to enter the. So I think, like going back, like I would learn something on the side. I would always learn things on my uh, own, like on the side. But like if you want to structure your undergraduate education, I would like take classes that in areas that you're interested. If you're doing web development, I would take a lot of like classes in like those areas. I do a lot of stuff in. I've taken a lot of classes in like low level programming, like making then high performance computing, and like trying to port like some of the algorithms into like memory strapped devices like single board computers. So majority of the things that I focused on undergrad is just the computer architecture, operating systems, and then algorithms, which is on it. I took like a lot of advanced algorithms classes. Then I took like a bunch of computer vision courses by chance, and then I ended up um, like a lot of the work that I did at school was to making computer vision algorithms more faster and more like parallel and more memory efficient and more computer efficient. And that's the things that I liked, and that's what I ended up thinking I was doing. Um, can you suggest some good learning materials for computer vision? Yeah, I think this I would. Um, there's a class called CS 231N at Stanford. Um, I, that is not an introductory computer vision course. It's a introductory computer vision course with convolutional neural nets, and the first few weeks explains computer vision in a good way, and all the there's a version of the course online on YouTube. So this is a Stanford course, Stanford CS 231, and I took that course while I was working at NVIDIA, and it's a very good course. It was taught by this guy called Andre Karapathy, who's the director of AI at Tesla right now, who did a pretty good job at explaining stuff. After I took that, I would take that course. You would have a good idea about neural networks and a good idea about, like, very hasty idea about computer vision. Um, I can link some books in this the event page about and like material um, on computer vision, but like the CS 231 course would be like a pretty good starting point at this point of time, because majority of computer vision is based on neural networks right now. Are there other Sri Lankans in NVIDIA? And the answer is yes. There's like a few others. There's actually another Sri Lankan, although he was like born and grew up here, in my own team, who graduated from Stanford. There's probably around 10 of us, and I think like 4 or 5 of us. I mean, I didn't go. 4 or 5 of them did their undergrad at. Oh, never mind. I know a few people who did their undergrad in Sri Lanka. Yeah, there are like a few people at NVIDIA from Sri Lanka. What sort of a mindset do you should have to succeed in the industry? I think the biggest thing is like you have to be able to improve, like learn things pretty quickly. I think you have to be comfortable at learning things pretty at a constant pace. Like even when you start a job, like traditional um, traditionally, like this is outside computer science. Like you go to school to get a degree in an area, then you like do like very like repetitive stuff in industry. But in computer science, you need to learn um, like things pretty quickly, even in um, like day-to-day basis. Uh, like I spend like at least an hour every day, like not learning, reading like papers that are pretty in all different areas of like machine learning. There's a website called Archive Sanity where you can read the newest preprints. I'll link that also. You can sort by the newest. Um, I think you need to be able to learn new skills pretty quickly and then adapt. Sometimes, like, there are areas that won't exist right now, even within computer science, in like a few years. I think machine learning is pretty big right now, and any new area has this thing called S curve where you initially the adaptation is slow, then it becomes very like exponential, then it tapers out. I think we are in the second half of the exponential stage in machine learning, so like I don't think it'll last forever, but like I think you have to be able to adapt. Like let's say an area called web development. Like like a lot of the things written for the web, like let's say it's a programming language like JavaScript was written when the web was very um, in infant stage. So there are a lot of problems that come in like optimizing stuff and like the the stack and the development changes over time, and you need to be able to adapt pretty quickly. And you need to be able to devote some time every week or every day to learning something new, which happens like automatically if you're like writing code. Like you have to go and like read the docs, or you go to Stack Overflow and check what like um, kind of ideas are going on. But like sometimes you need to be able to learn completely new skills on the side. um, yeah. ah how do you learn new skills faster? I think that's a good question. I think you need to have a good I think this is like a personal opinion of mine. I think the um in like computer science, I think the most important thing, I think, is the ability to like read documentation and understand. So I think every time you go to Stack Overflow, every time you go to check a bug, um, you need to understand if you need to convince yourself that you understand the problem completely before like implementing it. Or like if you can do it immediately, you should need to devote some time to understand something at a deeper level. And you need to do that pretty much every day. Um, like, like I think there's a famous saying that like if you can't explain something uh, to at a very rudimentary level to someone who doesn't know the subject, you don't understand the subject pretty well. So you need to explain that those things, like any area. Like you need to get to a point when you where you understand something that you can explain it to someone else who doesn't have any idea about it. That's when you know the subject pretty well. Um, like be pretty good at reading documentation, and then be pretty good at taking like for example for me, I think the biggest skill that I learned in my job was and at school was reading a paper, and like in papers you don't have code, you have like a algorithm section which gives you like a pseudocode. Um, applying that to like implementing an abstract idea in like math or code is a pretty good skill to have. Um, I think this is a hard question. Like, how do you learn new things faster? I think the best um, um, the best thing to do is like have a good fundamental idea of like a lot of the key areas that you're learning, or any skill. Like, let's say if you want to learn like neural networks, or if your applications are in computer vision, try to learn like the math and the areas of that at a pretty deep level. And this is a hard question because there are a lot of like extraneous stuff that you would learn, um, and you need to know when to not read things or when to not learn things also. So it comes with experience. I can't tell you um, like just I mean, the good thing to do is like if it's like something area like computer science, I can answer things offline, called computer vision or like computer architecture, which I also have a really good background. Um, um, does taking in a computer as a class degree help in industry world? I think it depends. So like there are people like who are doing web development, they don't really know about computer architecture a lot. But if you're doing like low level optimizations, computer architecture matters a lot. Like you need to learn about like caching, memory, the memory hierarchy, um, page tables. So if you are trying to do pretty like write code at a pretty low level, which for that there is a huge demand also. There aren't a lot of skilled people who can write performant, closer to the metal code in either C or C++. You need to take a very in-depth operating systems and a computer architecture course. Um, if you do take computer, like um, if you do take computer architecture, sometimes like you would the things that I learned in school was to write stuff in this language called Verilog, which would mimic a hardware. Called a hardware description language, so it will predict how a hardware, like at an abstract, pretty high abstraction, how it would behave, and like how the timing happens. And we wrote like Verilog code to mimic a MIPS computer, which is like a very rudimentary um, instruction set and like a 5-stage pipeline. I don't think I've used that a lot like anywhere else, but it was a good skill to have. Um, if you were to start over your career over again in a bachelor's degree, what would you do differently? So when I first started my undergrad, I didn't really um, know a lot about where I wanted to be. Like when I was in, so another thing that I didn't say this, like I got into like University of Monterey, and I was always going to go, and like if I, like if like so this was like 9-10 years ago, like this was like before like computer science was like pretty huge. The like a lot of people, what I saw was they would go work for like MAS or dialogue. So like the areas that people would concentrate were mostly on like telecom. So when I first came to the United States, I didn't really have an understanding of what I wanted to do. So I did took a bunch of classes in electrical engineering, and then I realized the part of electrical engineering that I really liked was an area called digital signal processing, and um, so that has a lot of overlap with computer vision. And in the area that I really liked in computer science was low level architecture, low level writing performant code at. So I didn't really have a good idea. So if I would start again, I would probably not take a lot of classes in something like. That's a good. I wouldn't take a lot of I took a programming languages course in university, and I mean there are a lot of things that you don't know if you are if you wouldn't like it until uh, you would taken it. So there are certain things that I have taken that I don't think are that useful, and I can learn it on the side. For example, um, I took a pretty advanced programming language class, which isn't useful for what I'm doing now, but it might be useful later on. I didn't really know. I wanted to do computer a lot of um, computer stuff related to high performance computing or computer architecture. Like when I first came, if I had that insight, I would have moved there earlier. And it's I think that is something that's very somewhat unique for in the United States. You can change your major, you can change your degree sometimes. I never I think that's just not as flexible. Let's say University of Marto, you the first year you do a general engineering, and at the end you choose based on how well you do the first year. Um, so I would um, like if you are someone who doesn't have you're not at you're doing an undergrad yet, or you're about to do your undergrad, I would really have a high level understanding of what you want to do the rest of your life, and that's pretty not easy. Sometimes the things that you want to do don't pay you well, so um, so it's a challenge. So if I would go back, I would take more computer science courses and less electrical engineering courses. But there are definitely electrical engineering courses that I would retake. Oracle certified programmer, I am not the best person to ask. Um, OCP, and I, I don't know a lot of people around me who um, who have that. I'm assuming this is just some um, a certification to use the Oracle stack and Java. I'm assuming Oracle certified programmer. Um, yeah, I think Java is a. I mean, if this helps, I don't know how much this helps. Um, I think you can learn a databases without learning getting the certification, but I don't think I'm the best person to ask that discussion. Um, if you're asking me what cloud provider that I would build a stack on in 2018 or 2019, I would definitely go with AWS. I think AWS is uh, like the most used stack. So there are other things that are pretty good. They are like their key value database stuff is very performant. So um, if your long-term goals are building something on the cloud or like on the web, I would use the AWS stack. Okay. So what is your future? Okay, what are your who are your mentors and how have they helped you to get to a place? It's a good question. I don't. So a lot of the people that I learned, like, or got an idea about the industry were um, the people that I did my undergrad in and the people at NVIDIA. I think I and my advisor in my undergrad. I think what you want to know from your mentor is to give you like a very like high level overview to guide you in like a specific area. Let's say computer vision. Um, this is an area that's unexplored, and this is an area that's explored. So devote your time to a specific area. So I don't know, like I don't think like who my mentors are pretty important. Like they are people you know and meet, but like if you're trying to find out who is a good mentor, is someone who has can give you a high level overview of an area and then can direct you to do explore on your own like on the pretty low level stuff. Low level means like a very in-depth stuff. So example, let's say computer vision, like is like what are areas that are pretty useful now. Like if I'm being a mentor, is I'm trying to get neural networks more performant and more memory efficient is a huge um, area of research right now. Like making existing uh, computer vision algorithms run faster and uh, run with less memory, and essentially like the goal of every like computer scientist is like run an algorithm faster and using less resources. So the first few years in like neural networks were spent on like finding the best algorithm to solve like what gives the best performance now in terms of like like the metrics of computer vision. Now how can you take that algorithm and make it run faster and use less resources? So that is kind of similar to like um, what are the things that the future job market. So I think the this we are moving to the second half of like the end of like the neural net revolution. I think now the big thing to do is how can you run applications on how can you make existing neural network algorithms faster. So that's a huge area of research right now. And the other big thing is how can you use neural network like existing, let's say, a computer vision problem and port it to like other areas, right? Medicine, weather, that sort of things. Um, um, uh, then like a lot of a lot of neural network architectures are going to be part of like a stack, or like neural networks are going to be part of the stack the next few years. So the big thing is, are they secure? Like security is a huge thing. I think a huge area in general, because like that is going to be pretty big even without like neural networks in the picture, because we have all these devices running, and you like give like all your personal information, and now we have cars, and if people can access data and access control of those um, things, um, uh, how do those things like how can we make these systems more secure over the long period of time? I think security is going to be the next big thing in the in terms of like even neural networks. You can try to like an example that this is a pretty huge area of research called adversarial attack. So let's say you have a neural network trying to predict um, like a self-driving car, like what you're seeing is um, a pedestrian or another car. And if you can change the network really slightly, and you can predict mislabel, which is like if your system's predicting a car and if you can make it predict it's a pedestrian or the other way around, that has huge ramifications of how those systems are used. So I think security at like all different levels are going to be the next huge thing. So I would, if I would go to that ties into, I think if I would go to school right now, another area that I would focus on pretty extensive would be security. I do talk about electronics. Do you still use the knowledge as a software engineer when you're not really? You don't really need like what a transistor is, but it's you can learn that at the job. Like especially like the job that I am doing has a you trying to sometimes port circuit design algorithms as like graph search problems, and then use machine learning to make things faster or like predict things faster. So you do need like a low level understanding of like what a transistor is, but you can learn that on the job. Can you talk about using tensor cores for mixed precision training? Also, can you tell me if is what mixed precision? I'm assuming integer and floating point. Like, uh, yeah. So this is I don't know how this is a very open-ended question. Um, so I think what he means by is um, like GPUs or like circuits only have very limited amount of like floating point registers and floating point units. So sometimes you can port you can use the integer floating points as to mimic floating point behavior. This is not something that I've done extensive, but I've done this in the past. Like I can this is usually a huge issue if when you're using very compute limited things. Like let's say you have a processor in a car, you only have a very limited amount of floating point units. So then um, a neural network works such a way that you need to calculate gradients. Um, oh, sorry, not that's during training, but during inference you need to propagate the values front. So you need like a huge like multiple like matrix multiplication operations, and you can do it at like some of them at integer precision level. Um, but I don't know if that answered the question. I don't know if your question was related to training or inference. But like I would, if you can follow up that question, I can answer that. Can you tell me if it's worth purchase a RTX card to do deep learning research? Uh, uh, yeah, I mean, um, tell me how much money you are willing to spend, and I'll tell you what the best card to you. Is Python good for developing neural network? Yes. A majority of frameworks, like neural network frameworks, are written in not written. They have APIs in Python. So I would definitely use that as the starting point. Um, how has failure or apparent failure set you up for later success? Do you have a favorite failure of yours? Um, yeah, like a lot. uh, I think like, this is true with research in general. Like a lot of the projects that you do end up not working, and which is I think like unfortunately the way people reward things in the scientific process is you really care about new things. Like if you explore area that things works really well, um, um, they reward you in terms of like your paper gets accepted. But if you like publish something, say this is not going to work, people are not going to really care. So there were like a lot of things that I did in the first year of NVIDIA, like which was just my manager just told me like um, do like explore a lot of open-ended problems, and what had ended up happening was a lot of them didn't work, but that's true of research in general. Um, I have I've worked on a lot of projects, and like a few helped out in a few startups when I was in school, and they didn't end up working at all. Um, yeah. I think the key to like understanding failure is just learning what works and learning what doesn't. Uh, and like sometimes you don't know what works until you actually try it out. And then when you do something similar, or like when you try to solve a different problem, try to take your experiences of that problem to the next level. Savind, anything better? The answer is no. Can you talk about? I also already answered that. How would you explain the importance of career network and security in terms of jobs? I didn't understand. Like those are different questions. Career network. I'm assuming like the people, the type of people you interact with. That's like pretty huge. Um, I think it's always like if you are someone who doesn't have a lot of experience, is like the best way to get your foot in the door, like like at least here in the United States, is to talk to like people, and especially people in those positions, and try to sell yourself and sell the work that you're doing. Um, I think, and that is huge. Like I think, like the way I found my internship was just like talking to a person at a scientific conference. So that I'm not someone who talks a lot or like tries to socialize a lot, but like it didn't help helping a lot. So if you, and this is pretty big in Silicon Valley, like you have like a lot of meetups, and um, I there was like cryptocurrencies were pretty big like a couple of years ago at Stanford when I was taking classes at Stanford. I mean, I'm still doing that. They were So I got into like algorithmic trading, which I had done previously, but like I got into cryptocurrencies pretty early through one of my friends at Trinity, and then like I like heard a lot about what's happening at um, Stanford. So like networking is huge. So you just want to talk to people um, that's very close to the problem. So Silicon Valley is a pretty good area because that's the best things that happen in the world in terms of computer science happen here. That is my, I think, opinion, and I think there's a lot of data to back that up. Um, I'm not sure about like how security, like job security relates to career network, but like if you want to get your foot in the door to a job that like sometimes you feel like you want to stand, you can't stand out, you should talk to like recruiters or people who work at that job, definitely. What will be the next big tech after ML, AI, blockchain? Oh, this is a good question. If I could tell you this, I would be pretty rich. I think, I answered this earlier. Then I think I don't know how big will be in terms of like money, but um, uh, in terms of machine learning right now, the big thing is not trying to find the best, like the most performant machine learning like solution. I mean, that's still going on for certain applications, but like how can we make that algorithm run like really well at scale? So that's what a lot of people at like NVIDIA or like Google or Amazon, so AWS and Google Cloud are really trying hard. Like, same with NVIDIA, to make you or like anyone else run uh, like machine learning applications at scale, which is huge. I mean, Google and Facebook and AWS, Amazon does that automatically. I think Microsoft does that too. Like so big, like large even NVIDIA, large corporations use like a lot of machine learnings internally, and like places like Google and Facebook, it is part of their core product, so they have a lot of experience with that. So the next big thing is how can you let other people run their own products on top of that. So like example is like Netflix. How this is actually like a very like how can you predict what you're gonna watch next, and those are like um, been areas in machine learning for a while. But like smaller and smaller companies are getting in. So how can you let like how can a big company like AWS or Google Cloud let you run those applications at scale? And from AWS or like Google or Facebook or like even NVIDIA standpoint, they are what they are trying to do is run things more efficiently so that the server uses less power, and um, they save money and they get more customers. So I think the next big thing is to make. I think the short term, the big thing that's happening going on is making machine learning applications run at scale. Um, I think I have in terms of blockchain. I think a lot of the blockchain applications are going to be on uh, pretty ubiquitous or like pretty prevalent everywhere. The problem with blockchain and like cryptocurrencies is the majority of the people who want cryptocurrencies to like expand are also people who want, as soon as they like may become popular, to convert those cryptocurrencies into like US dollars or their own fiat currency, which is not really what I think the core of what blockchain is. So I think the technology is going to be pretty prevalent. I don't know if like if your favorite cryptocurrency is going to go up. So I don't know if that's going to be a question. And I think long term, I think like the next 10 years, the big thing is going to be security. So if you have a self-driving car, how do you make sure um, someone doesn't like hack like someone doesn't get into your car and stop it or like make it crash. Um, the coming with the self-driving car, like I'm assuming it's going to be a pretty huge area how to make like a lot of multiple um, small systems that work on its own. How do you make it so that they operate efficiently? Like how do you have like 10 self-driving cars? I think it's called swarming. Behave um, pretty efficiently together. That's going to be a pretty big area in like a few years. There's a lot of research on swarm robotics right now. I think robotics is not as mature as like because like the hardware hasn't like robotic arms or like the motors or um, like haven't come as far as like a lot of the software applications of machine learning. So I think robotics is also going to be pretty big. Um, okay. So security, long term, making machine learning applications run in scale, short term. How is the culture like at NVIDIA Silicon Valley, and how it affects you as a person? Um, I think this is also my understanding of, or like, this is based on my limited sample size. I think in terms of cultures, I think and India has like a really good culture. I like, I think I have like a huge, in terms of like companies, compared to a lot of other places. I think I have a pretty good work-life balance, and I solve problems that I like. I mean, of course, like there are weeks that I work for a long time, but it depends a lot on who your manager is and not your company. But the famous in Silicon Valley, um, the anecdotal evidence, so don't take it with a grain of salt. So I have only a very limited amount of people. I think Google has a very good culture, and you learn a lot of new things. And I think a lot of things that you learn at Google is transferable, which I hear, but I haven't worked at Google. Um, I think, and the other big company is Facebook. I think the like um, the anecdotal evidence or like the um, idea of like a lot of people who work at Facebook or work around me are like the work-life balance at Facebook is not as good as, let's say, Google or NVIDIA. I think Apple, uh, it really depends on like the team you are in. There are like teams that are like focused on products that are very, like you have very big deadlines that very like deadlines that are very strict, and like sometimes you have to like work like 80 hours a week to get there just before the deadline. Um, there was a story in New York Times like 3 4 years ago about Amazon, and like even the engineers, they as like that they work like really hard, and they overwork you, and apparently um the work-life balance has gotten much better since. But the caricature of um like Silicon Valley, when like a lot of people look at Amazon, is that they overwork you. I don't know if this is necessarily true. I haven't worked at, so I can't really answer that, and it's most likely the people who like have the bad opinions. Their opinions were more um, loud. So I think that's the reason why those caricatures and like bad labels exist. I think NVIDIA is probably like the reason why I like came back after my internship was because I really liked NVIDIA, like in terms of like a lot of the people that probably have my job at, let's say, Google or like a Google Brain probably have a PhD. So I didn't have those resume to work there, but like I ended up working pretty important problems currently. And while not working, um, I think what's really important in your first job is, are you um, comfortable? Like, are you like learning things very fast, and do you like your managers? If you don't, if the answer to those two questions are no, just like leave your job. Or if you can, if you can't, like I wouldn't. What do you think about cloud mining? Depends. Depends on the cryptocurrency depends on the hash rate. 2 years ago, it was pretty profitable to mine Ethereum on a GPU. It's not as profitable to mine on your own GPU anymore. Now you have to, like then in 2000, early 2018 to mid 2008, you had to join a pool. Even then, I don't think it was that profitable. Um, it depends. It depends a lot on a lot of things. Is it the hash rate of the cloud, hash rate of the your cryptocurrency, and how what the algorithm it uses. Like so, for example, Litecoin doesn't run really well on GPUs because that's specifically targeted on the it doesn't use SHA encryption, so you can't make it run faster using GPUs. So it really depends. So there's a myth that being a software engineer by profession is stressful. So what do you think about that? I yeah, I mean like um, it really depends on where you work. I think if you are like a startup that's like struggling to release a product, then it is true. It's very stressful. I think initially, like when I joined my first job, I didn't feel very comfortable of myself because I felt like I was not as smart as like a lot of other people, and like everyone in my team except for me is probably from like three or four schools, which is Stanford, Carnegie Mellon, and Berkeley. So I felt pretty out of place. So I wanted to. So I worked pretty hard, but you realize like you wouldn't be at the job if you weren't as smart as well. Then I think the thing with software engineering is you need to understand what like you need to have a good project management system, or you have a good project manager that allocates tasks pretty efficiently, and then you have to be reasonable with him or her and with yourself, like what are the problems that you can solve in the time they give, and you need to give like it's a loop. So you need to set the expectations such that you are solving, like you're meeting them. So like don't give too high of an expectation and don't slack off. So and give too low of an expectation. What age did you start coding? I think when I was like when I started my A level, so like 16, 17. tell me about your package, current receiving, and benefits that motivates us more. I don't know if I'm allowed to do this publicly. I think I'm, of course, doing this internally. But I can tell you, like, approximately what straight out of school, what like software engineers make. Um, the big, like the companies here. Um, I think people make around like $120,000. I think that's like like you should go on a site like Glassdoor out of school in terms of salary, and they probably receive like the same amount of money in like approximately the same amount of money in like stocks at Google or Facebook or NVIDIA or Apple for that's spread out in 4 years, I think. Um, so like yeah, I think that's what I'm seeing. What the average is in Glassdoor. So this is not my personal. This is like average. If you if you if you use Reddit, you can go on the subreddit CS career questions, and they will like every year there's going to be people anonymously posting their salary. And I think that's where I got the number from. Like the starting salary for someone with a bachelor's or a master's is usually around at Google, Facebook, like all these big companies, around 120,000 in terms of salary, and um, then you get like equal amount, the same amount of money in like stocks. Um, I don't know if this is too low, but or too high. One last, do you like to work back in Sri Lanka and make some kind of Sri Lankan mark on global software industry, or just absolutely yes. I think I would really like to get in touch with some people who I would like to work on like projects on the side, and maybe like help with their like startups. The next few years, I don't think I have any idea of going back to Sri Lanka at least. But I would definitely like to collaborate in terms of research. Um, I think I mentioned this before. They're like you anyone who wants to get into like machine learning, or there are like a bunch of competitions happening every day and every like year, and like so if someone wants to collaborate and participate in a competition like that, and I'm pretty down. I can mentor you. I've done that like already, like here, like with a few of my friends who are doing undergrad, a few of the people I went to school with. Uh, my role is like a software engineer. Um, Samita, let me get back. Um, FP16 and FP32, like using FP16 tensors for input processing and FP32 to compute loss, update the weights, and then convert it back to forward and backward passes. Okay. Sure, that is fine, but like, why do you only have limited number of FP16 and FP32? Like, what are you trying to solve? Like, I mean, this is probably a very interesting problem, and like, of course, like there are networks that you can. I think what you're asking is what's the best way to utilize the different types of precision floating point to. I mean, that could be a way. I'm not sure if like I agree with you. I have seen like a lot of the work that I did back in the day was like, this is like very way back, like when we didn't even have enough floating point, was through how to move some of the floating point computation to integer. So I don't know. I can probably look through and see if there are papers like looking back on using expression. There are like, of course, there are like there's ways to rank different weights to different, or the different layers to different um, floating points, which I've seen. Um, mm, so FP16 to input processing. Like, so why I still don't understand like why you are limited by floating point units during data preprocessing. What are the common traits you see in great software engineers you have worked with? Oh, so I think the one, the ability to read documentation really well and implement something. Two, like if there's a problem they understand things in a very deep way. Like, so like something like, let's say a simple bug, you go to Stack Overflow and you find a solution, not just like just copying that code back into your own project, but like understanding what the problem, so that the next time this happens, you solve a lot of other problems with it. In every software engineering project, you have a concept of like how much do you want the code to be performant and how much you need it to be like readable, and like there are different metrics like how much that all depends on your like deadlines and stuff. So um, let's say you have unlimited like time, then I would like make like all kinds of optimizations and all kinds of like make the readability, I mean readability like so like, and the ability to expand the project really high. But if like I have a limited amount of time, I would like implement something very quick and dirty, and then but this is the way I do it, like implement like an end-to-end system very quickly, and then I optimize each step separately. But I still have like a high level idea of like the project. What are the skills and years of experience you need to apply to any other companies, and how you apply them for? So NVIDIA hires most of your, the previous question, are you an expert on Swift now? I haven't done a lot of like work on apps on iOS at all. I have done a little bit on Android. What are the skills and years of experience you need to apply for NVIDIA and other companies? Depends on the role. I think any software engineering role, you need to have a good understanding of data structures and algorithms. And there are other things that you might be asked to know of, like, say, for example, do you know Docker or containers, or have you used that? Like, like if you go to Netflix, which uses the AWS stack extensively, do you have an experience with AWS, um, and how can we apply them from here in Sri Lanka? I am not the best person to ask that. So I think I know a few people who have directly come and worked at Google from Sri Lanka, um, and a few of them did like win like programming competitions, like top code, and then they came through. I think I think the main things to do, I would say, is improve your algorithm and data structure skills every day. Um, Contribute to a good or start your own open source project. So this is for general software engineering. Um, if you can write a paper on like your favorite project that you're doing. If for machine learning and data science, there's a lot of big competitions out there. Um, Try to submit solutions to them and make your code open source so the people can read it. Um, I think in any software engineering job, what we want to see is, can you write code pretty well, and do you have like good software engineering principles? Can you implement something looking at a paper? Sometimes, like for the job like me, so um, and like if you don't have an internship, if you are in Sri Lanka, like my best advice would be to contribute to an open source project, or like work at a company that's pretty visible as an intern. Um, how long does it take to learn machine learning and AI to a level of where you can develop an image recognition and Android app, let's say, that can recognize objects like you mentioned before, and what are the best frameworks to check out to do if your project has short time period? I think like at least a few months you'll need to understand. So I assume that you already know a little bit about, or that you already know about Android apps. So you need to know the like how to create an image recognition pipeline. That should take you like a month or two to understand if you're good at Python. And you'll need like, since you're using an Android app, I'm assuming you're going to use TensorFlow or TensorFlow serving, which lets you write like very like lets you write things at scale. And then you have to make your Android app like send that message of the image recognition to a cloud, and the cloud will perform that operation. So you need to be able to run things on the cloud also. So it's very unlikely you'll be able to do all the data processing on the phone, because it's not that compute intensive. Um, what what are the best frameworks to check out if you want to do the project in a short period? Um, there is a project called TensorFlow Lite. Um, I haven't looked at this in a long time, but I can. There's a project called TensorFlow Lite. There's a Android Quick Start. So it's essentially like a page, like a it's TensorFlow ported for IoT and mobile devices. So I would look at um, that, and there's an Android quick start page. I just looked at that. What is one of the best or most worthwhile investments you ever made? Um, I learned I can tell you at different stages. Like if you're like first year undergrad or like a undergrad in or like like you're still doing your A levels, I would learn like programming language like Python and learn like data structure. It's pretty deep. I think the most important, the best investments that I've done for me is um, I learned um, this parallel programming paradigm called CUDA, which lets you write C++ code and port it right on the GPU. And I learned that a lot essentially on my own. That kind of opened my a lot to a lot of different projects. I think you need to find out areas and things that are going to explode in a few more years, or like expand a lot and try to gain the skills at a very early stage. For example, like uh, I have a lot of bad, uh, like I'm not a huge fan of JavaScript, or like not JavaScript, like a lot of the web frameworks that are out there that I don't think they're that performant. And I found this um, web framework through a programming language called Elixir, which was written with performance in mind. And so, and like, if you guys want to, if you're going to go in web development, think of what the web's going to be in 5 years. You went to high school is in Sri Lanka and you moved to college in the US. What are the difficulties faced in Sri Lanka and how did you overcome them? I think like if you're like from India or China, there's a lot of huge even undergrad population from both of those countries, but there's not a lot of Sri Lankans in the United States. There's a lot of Sri Lankans in the Silicon Valley and Bay Area, but like where went to school in Philadelphia, there weren't a lot. Um, the biggest problem that I um, had was just like I didn't understand a lot of cultural context of things going on. Like let's say you were taking the SATs, you would read like a paragraph and you had to answer, and I understood all the English portion of it, but like sometimes the questions were based on like, let's say, American football or baseball, which I didn't really understand, or like American history, which I didn't understand, or American holidays, which I didn't understand. So the first few years was just like me trying to get used to the United States, and it was really sometimes kind of hard because I like I knew all the people that I went to school with from grade 1 to grade 13 in Sri Lanka, and it was kind of hard to move out. Like I had the same group of friends, and it was I when I went to the United States, I had to make new friends, which is kind of hard. But like it has come full circle because like a lot of my friends from high school who actually now uh, tuned into this live chat are very close by in California and in the west coast of the United States and Canada. So I meet them pretty often. Um, so like the other big problem, like a lot of Sri Lankans have, is just like financial aid. Um, college in the United States is expensive. I wouldn't have come here if I would. It was like a significant portion of, or like most of it was paid for. Which year did you move to US? 2009. Do you think DNS affects being positively, or does it even? What? Okay, I think. Right, it's past 9:30 p.m. in so I think Shazini, your question was like I would take a look at TensorFlow Lite or like TensorFlow for Android. So it will give you a good overview. But if you want to make things performant, you'll have to learn a lot of other skills like running things on the cloud. All right. I think we're gonna wind up now since I've gotten like 15 minutes of over. And if you have any other questions, just ask them on the and I'll try to reply to them. Thanks a lot, and thanks a lot for Bonica and Hasita to getting me involved. And if you have any questions, just message me. Thank you.